All right, welcome to this lesson on transformations of functions. It gives us the ability to see more clearly what a graph might look like without going through quite so much effort. Here we have the basics of transformations, all of the different things that can happen to a basic function to change it. Let's say for all of these, we'll use this graph here. We are going to use the basic function y equals x squared, and we'll do some transformations on that function. So the function y equals x squared is one of our very basics. We see it often in mathematics. You have a point at 0, 0. We would have the point 1, 1 would be on the graph, and the point negative 1, 1, and so on. And it forms a parabola. Okay? Anytime you have a number added to the end of that basic function, notice it's not inside, but added to the end, and for x squared, this would look like x squared plus 2. That moves the graph up. That number changes your y values. Anything happening outside of the function changes your y values. Anything happening inside, so inside that x squared, would change our x values. So this function would move everything up to, so instead of 0, 0, we'd be at 0, 2. And instead of 1, 1, we're going to be at 1, 3, and negative 1, 3. So notice it took the same shape. This shape of the graph did not change. All it did is move the entire graph up 1. Let's take a look at the next. If we subtract, so the next thing that we can do is subtract from the function. So if we had x squared minus 2, okay? Notice that's not within the x squared, it's on the end there, so it changes our y values. That's going to move the entire graph down 2 instead. So our points would be here at 0, negative 2, and then at 1, negative 1, and negative 1, negative 1. Again, we have the same shape, it's just been shifted down. Now we come to things happening within the function. Notice this looks different. It's f of x plus 2 quantity, and the plus 2 is not on the outside there. For our x squared function, it would look like this. It would be x. Let me get a different color. Sorry about that. Go with green. It would be x plus 2 quantity squared. Notice the difference there. This provides changes with their x values, and anything that happens inside with those x's works opposite of what we would think. Normally a plus 2 for x values we would think to move to the right, but because it's inside of the function, it works in the opposite manner. So this would actually move us to the left 2. So we would take our basic function and move us 2 to the left. So instead of 0, 0, we're at negative 2, 0, and here and here. So we've taken that basic graph and we've shifted it 2 units to the left. Similarly, when we have subtraction, opposite of what we would think, okay, so this would look like x minus 2 quantity squared. Notice the difference from this up here. Okay, anything inside those parentheses is going to change our x values, and it's going to change it the opposite. We would think minus 2 would move it left, but it actually moves it to the right 2 units. So we would be here at 2, and that purple parabola would be our x minus 2 squared. Okay, so we're getting a lot of images there. I'm going to go ahead and clear the screen. So those are our first basics that we have. Okay, so again, I'm going to go ahead and erase so that we can carry on and describe some more transformations. Okay, so then I'm going to go back to our basic graph. Of y equals x squared. Okay, so we talked about if you add 2 to the end, it moves it up 2, or whatever you add to the end moves it up that many. If you subtract from the end, that moves it down, or subtract from outside of the function. If you add within the function, that's going to move it left. Subtract within the function, that's going to move it to the right. Now we have negative. Okay, if there's a negative multiplied by your function, so in this case negative x squared, that is going to reflect over the x-axis or flip it upside down. So it's going to look like this instead. Again, anything happening on the outside affects our y values, so it makes all of our y values negative, or the opposite sign. If it's inside the function, and that would look like this, okay, the negative of x squared, it reflects it over the y-axis, which is just going to reflect, since that's our line of symmetry, that's just going to give us our graph over once again. And notice if we simplified this and squared the x, we would come back to our regular function. But a negative inside of the function with our x, that's what it does, is reflects it over the y-axis or flips it sideways. The last thing we have to talk about down here, and I'll go ahead and draw a new graph for us again. Okay, with our basic function, we're going to talk about stretching and shrinking. Okay, the same thing goes. Anything that's inside is going to affect the x. Anything outside the function will affect the y. Okay, so first thing, if we multiplied by a 2 in front, okay, so that would look like this, 2x squared. That stretches vertically by a factor of 2. It multiplies all of our y values by 2. So we would still be at 0, 0, because 0 times 2 is 0. Okay, it doesn't shift it at all, it just stretches it. So instead of at 1, 1, it would be at 1, 2, and at negative 1, 2. So notice it just stretches it upward, makes it a bit thinner. Okay? 1/2 f of x, that is going to shrink our graph vertically, so kind of squish it down by a factor of 1/2, and it would look like this, 1/2 x squared. It's going to cut our y values in half, which would again put us at 0, 0. We'd be at 1, 1/2, and negative 1, 1/2, which notice just shrinks it vertically, kind of makes it a little squattier, if that's a word. Okay, next thing is if it happens within the function. So f of 2x would look like this, 2x squared. Okay, now remember, anything inside is opposite of what we would think. So instead of stretching by 2, it's going to shrink it by 1/2. You do the reciprocal. Okay, so it's going to shrink our x values by 1/2. So instead, we would still be at 0, 0, but instead of 1, 1, we're going to be at 1/2 and 1 and 1/2 and 1. Notice it does overlap. It's the same as if we did the other. Okay. Now, if we had 1/2 x squared, again, you do the reciprocal. Okay. So that's going to stretch it horizontally, sort of pull it out sideways, okay, by a factor of 2. So our x values, I'll do this in purple, would be at 2, 1, and negative 2, 1 for our x values. Notice that stretches it horizontally. Now that can be confusing because kind of stretching horizontally and shrinking vertically seems to do the same type of thing to the graph. But what you want to look at when they're asking you to say what is changing on the graph, you want to look at where the multiplication is located. If it's located outside of the function, like it is here, then it's going to be vertical stretching if the number is greater than 1, shrinking if the number is between 0 and 1. If it's inside the function here, with these parentheses indicate, it's going to be shrinking horizontally if the number is greater than 1, because remember it's opposite inside, and it's going to be stretching horizontally if the number is between 0 and 1. So these are the basic transformations, and let's go through some examples that